We already started listing all permutations. For the first video, we have an element, or we have a set A with 3 elements. This time we have set A here with 4 elements. So we're still going to follow the same. Now, permutations again is a bijective mapping 1-to-1, and both 1-to-1 and onto, and we're going to write it in this manner here. This would be the mapping 1, 2, 3, 4. That would mean all elements must have a specific mapping. The first permutation that we could do is when we map the elements to itself. This is actually your identity permutation rather, which is considered as your raw sub-zero. Okay, that's the first permutation you can do. Now, for this time, we can also list down all permutations of set A here following a certain square where the vertices are your certain elements 1, 2, 3, and 4. The first 3 permutations are actually results if we are going to rotate the vertices of this specific square. Say, for example, I'm going to rotate it here, rotate it like that, rotate, and rotate. That would mean the new location of 1 is here, the new location of 4 is here, the new location of 3 is here, and the new location of 2 is here. And if you can see here, just by this pairing, you could see that the element 1 is now mapped to 2. Okay, so writing it like this is actually your row sub 1. You still have 1, 2, 3, 4 here, but now your 1 is now mapped to 2. Your 2 is now mapped to 3. 3 is now mapped to 4, and 4 is mapped to 1. That's your first rotation, your second permutation. Your third permutation here is when we follow the same rotation, but we rotate the red vertices now. So, for example, rotate that here, 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 and here. This would mean your 2 now is here, your 1 is now here, 4 is here, and of course 3 is there. Now, looking at the original vertex, you have 1 and the 3. This would mean 1 is now mapped to 3. Your 4 is now mapped to 2. Or let's do it starting here. Your 2 is now mapped to 4. And your 3 is now mapped to 1. This is your third permutation. Our fourth permutation is, of course, continuing the same process. 1, 2, 3, and 4. And the blue vertices now, will be rotated from here to here, here to there, here to here, and here as well. Let me use another color, let's say yellow for this instance. So your 3 is now placed here, your 3 is now placed, 2 is now placed here, your 1 is placed here, and your 4 is placed here. Using the original vertex, your 1 is now mapped to 4. So 1 is mapped to 4, your 2 is now mapped to 1, your 3 is now mapped to 2, and your 4 is now mapped to 3. This is now your third rotation, but your fourth permutation. Look, as you can see, there are no repeated patterns here or repeated permutations, so they are very different from one another. Of course, if you're going to continue further and add one more rotation, your 4 here will just return to the original 4. And take note, that's your identity permutation earlier. Your 3 will return here, your 2 will return there, and your 1 will return here. So again, we will just return to our identity permutation. Now, where can we find the rest of the permutations? In our previous video where we solved for the permutations on a set with 3 elements, we use equilateral triangle for that. We use the idea of perpendicular bisectors. Here, we're also going to use the idea of perpendicular bisectors, but the bisectors will not touch any vertex because we are on to square. Let me use another color here. Let's say, for example, this one here. So it should be square. So more or less like that. 1, 2, 3, and 4. We are going to come up with perpendicular bisector for this side, but it will not pass any vertex because it will also be dividing or yeah, bisector, and as well at the same time perpendicular to the other side as well, because that's the property of a square. And with that, assuming that my line is approximately correct, with that we are going to fold or reflect each side. Therefore, once we do that, year 1 will be mapped here, year 2 will be mapped here, 3 is here, and 4 is here. And that is your fifth permutation. We call this here the mu sub 1. The flipping against the perpendicular bisector. So again, we still have 1, 2, 3, and 4, right? Because we have those elements. So 1 will be mapped with 2. 2 will be mapped with 1. 3 will be mapped with 4. And 4 will be mapped with 3. That's your fifth permutation. The other one is, of course, if the perpendicular bisector will pass through this side here. Okay, let me use blue color here. Once we flip that, your 3 will be placed here. Your 2 is here. Your 1 will be placed here. And your 4 is there. Look at the vertex, the original vertex, the black text vertices, and the blue. That is your new mapping here. So that's your mu sub 2. 1, 2, 3, 4 still, but year 1 will be mapped to 4. As you can see, I will be checking it later. There will be no repetitions. Year 2 will be mapped to 3. Year 3 will be mapped to 2. And year 4 will be mapped to 1. As you can see here, 1 mapped to 4. This is when you're 1 mapped to 4, but they are not the same all throughout. So they are different permutations. So we are down to our remaining 2 because there are only 8 permutations for a set with 4 elements, and those remaining permutations will still be following this idea here: 1, 2, 3, 4, but the flipping or the imaginary line will come through this diagonal flips. Okay, diagonal flips there, and of course you're going to fold it in that manner. 2 will still be 2 here, 4 will be still 4 here, but 1 and 3 will be interchanged, and that will be your new mapping. This time, since this is flipping on diagonal lines, we are going to call it delta. Delta 1, okay? We still have 1, 2, 3, and 4. So delta 1 is now, delta 1 for 1 will be mapped to 3. Your 2 is still at 2. Your 3 will be mapped to 1. And your 4 will still be at 4. As you can see, for this type of permutation, 2 of the elements are mapped to itself. Okay, that's one of the trick there. You could see that one. And of course, the remaining diagonal flipping is somewhere here. And let me use the blue colored here. So 3 will still be 3 here. 1 will still be 1. But your 4 will be flipped, folded here, and your 2 will be placed here. Notice the black text and the blue text. That would be your new mapping, such as this. And that would be your delta 2. 1, 2, 3, and 4. So your 1 is mapped to 1. 2 is now mapped to 4. 3 is mapped to 3. And 4 is mapped to 2. So these are your 8 permutations for your set A containing 4 elements, or 1, 2, 3, and 4. Of course, if we have different elements, as long as we have 4 elements, so these are the 4 arrangements. So you have your deltas, your flipping, diagonal flipping, your mu's would be your flipping on perpendicular bisectors, and your raws would be your rotations. Of course, your identity permutation is still a rotation. That's your 4th rotation. It will still be mapped. The elements are mapped to itself. Okay, so thank you very much for watching.